辉达执行长黄仁勋爸爸开职缺啦！或许有些人认为一定要会写程式才能进科技业，不过仔细看看辉达近期释出简报设计师职缺，核心任务是与创意总监、艺术指导、平面设计师等人跨部门人员合作，运用现有的模板、图像、摄影和插图，协助设计简报还有文宣，传递品牌故事。有机会还能直接支援辉达高阶主管参与 AI 自驾车等重大产品发表。可以全程远距工作，年薪1等级最高上看约新台币649万元，引发民众讨论。只是应征条件需要具备5年以上使用 PowerPoint 打造品牌视觉简报实战经验，也必须能够适应长时间工作及高压环境。不只是辉达招人，马斯克创办的 XAI 近期也公开招募中文 AI 训练师，协助旗下 AI 聊天机器人提升多语言理解，而且职缺开放全球申请，提供全程远端工作模式，吸引不少求职者关注。如今科技巨头抢人才，不再只锁定工程师，显示在 AI 时代，跨领域专长也能成为进科技业的新门票。东森新闻综合报道。
We talked about several things yesterday. The most important thing we talked about, okay, if there's one takeaway, is that there's a new computing pattern. The architecture of an application. The architecture of an application, and this application is called an agent. The architecture of that is consistent throughout. It's called a harness. There are many different types of harnesses, but they're largely similar. They orchestrate the thinking process. The GPU still has to do thinking step by step by step. So it has to understand the context, the situation. It has to understand the intent, the prompt. And it has to reason about it, break down problems step by step, and think. And so the CPU routes the computing thinking from GPU, the CPU, memory to the GPU, so on and so forth. Okay? And that CPU sits inside the Vera Rubin rack, or that CPU sits inside the Grace Blackwell rack. Maybe another CPU has to move long-term memory to working memory. Maybe it has to activate a tool, launch a small tool, maybe use a browser, execute code, write code, maybe even turn on Adobe Photoshop. Okay, and so the CPUs would have to be used for that. But overall, the harness allows the AI to think and reason, use tools, work with memory. But that computing pattern is consistent, whether it's in the cloud, in a robotic system like a self-driving car, in a robot itself, and of course, we invented a brand new type of robotics computer, a brand new type of agent computer, and we call that RTX Spark.
We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that Nvidia builds. But Nvidia's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There are so many people to thank. I love my ecosystem here. I mean, there are so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was Agentic AI. And today, we can say that Agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of Agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay, and so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion, that $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. This is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model, or many, sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrate this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that you can act, that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codexit does an incredible job as well. Here's another example. This is the input. Create a GIF, Nvidia green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to Nvidia I logo, then scatter and repeat, right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool, create a CAD file, ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is Agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said, you know, Jensen, AI is coming, Agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough. And in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA-X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA-X libraries. Let's take a look. 20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science.